Welcome to this video tutorial. Welcome to my channel Shop Dev. So in this video I will be introducing to you the new C# 9 feature record types. Okay, so before diving deep to the record types, so let's have a look at the introduction, a little bit of history. So well, record types were just added in C# 9, so it's a new keyword. So in general, record types, or the record class is similar to classes in C#. It is similar to tuples. You can say that they are closer to structs, but as compared to structs, they are reference types and struct or value types. So there are two ways to create a record in C#. So we have basically two syntax that you will see in a short while. Firstly is the standard property syntax, where the properties are in the record type or immutable. Okay, they have get and set internally, but the set property are init-only. Okay. Secondly, we have the positional syntax, where you can create a record identical manner to that of a class, where the properties are mutable, but we can set the properties as init-only setters and give them an immutable behavior. Another important feature about the C# records is that when we use them, when we check for equality, so the equality operator just also checks the type and the field values to say that whether the two records are equal. But one thing is important to know, that the references of two different records of the same type are different. Okay, one more important feature is the new with expression, where you can copy an existing record, whether they are mutable or immutable, and you can modify them. Okay, so record types also allow inheritance, and they have a built-in support for display. So it displays a type when you call the toString of an instance. So it displays a type and also the key values, the property names and the values in a JSON format. Okay, so before diving deep into the subject, so let's see a difference between the standard property syntax and the positional syntax, which are very important for the next of this video tutorial. So on my left, okay, you can see the record type you created, defined using the standard property syntax. Okay, where you have the record keyword and a person record type with two properties, first name and last name. Okay, so to create a person record, you use format this style, declare a variable of person record. Okay, where you can set the first name and last name after the new keyword within brackets. Okay, one important thing to note that it is the properties first name and last name, well, they have a get setter, the get part in their properties, but the set part of the property are init-only setters. Okay, so by definition, like I mentioned in the introduction, so in this standard property syntax, the variable p1, its properties are immutable. Okay, so the next style, the next way to define a record is identical to that of a class, where you can define each member, each property using with the get and set part. But if you want to give them the immutable behavior, you can define the init-only setter. Well, if you want to learn more about the init-only setters, you can refer to my previous videos about init-only setters. Okay, and to instantiate a person1 record, you can do that using an object initializer, where you can define the first name and last name property. Okay, so we'll just have a look at the first way of defining a record, the standard property syntax. Okay, so consider the same example, a person record. So let's go in our Visual Studio. Okay, so here I'm defining the record person with the first name and last name property. And now if I want to create an instance of the person1 of the person record, so usually I should be using the person keyword, which is the record name, and followed by the new operator with the properties defined. And now if you see p1 dot first name, okay, the properties are accessible, okay, but I cannot assign a value to that. Okay, so the compiler fires me a warning, an error, sorry, saying that the init-only property first name can only be assigned in an object initializer of this. Okay, so we cannot reset the value of the first name property. So this confirms that the property members of this person record type are immutable. Okay, and now we'll just see how it is being displayed. So recall in the introduction section, I just had specified that it has support for the display. So when you display this person object, it will display the type and the property values in a JSON format. So just have a look here. So the type is person of the record, and the first name and last name, and so within braces, not JSON format exactly, but the property values and the property name are displayed. Okay, so that was introduction for the first way. Okay, now using the second syntax, which is the positional syntax, well, we can define our record in the same style of the class. Okay, here I've defined my record person with the first name and last name identical to the previous syntax. Okay, and now I can create my person instance, record instance, using property initializers, and I just do a console.writeLine to see whether it gives me the same output as the previous format. Okay, so just for information, you just don't need to specify toString in the console.writeLine. So just run the program again. So again, my record type has been displayed and followed by the property names and their values. Okay, so next we are going to have a look at the equality checks. Okay, so let me get back to my previous example. So I declare the initial syntax, which is the standard property syntax. Okay, so I will declare two instances of the person record type. So here I have P1 John Doe and P2 Tom Smith with the first name and last name respectively. Okay, so now I told you initially that it has a equality check support. So let's check what happens if we do the equality checks. Okay, so I just declare a variable here is equal. Okay, so let's check if P1 and P2 are equal, because okay, that's the first thing we're going to do. Is equal, and secondly we're going to check if their reference are equal. So by definition, when we use the equality operator, so here what is being done, the type of the records are being checked and each of the property values are compared. Okay, use reference equals P1 and P2. Okay, I just added breakpoint. Okay, so here in this case, in this scenario, the is equal should be returning me false, and the is reference equal should be returning me false. Okay, because different record types, I mean the same record type but different values, property values, and different references. Now let me do the same thing here. Let them have the same values. Okay, so here in this scenario, okay, P1 and P2 are equal because the properties are the same values and they are all the same type. So let's run our program to confirm. Okay, now is equal is true, but the references are different. Okay, so check the output again, true and false. Okay, so that's the beauty of the record types. So no need to write to do an operator overloading to check property values one by one. Okay, so the next point we are going to have a look is the new with expression. Okay, so like I said initially, okay, so I cannot modify a property first name with the standard property syntax. Okay, I cannot change the name. For example, okay, because they are immutable. However, with the new with expression, okay, with okay, I can specify the first name is equal to Johnny, for example. Okay, and now let's check the values. Well, we don't need the toString here. Okay, just for the demo, P1. Okay, and P2. Okay, so here normally when we do the with keyword, it creates a copy of P1. Okay, but the references are different. Okay, so here when I change the first name to Johnny, there should be no effect in P1. So let's confirm the explanation. Okay, so here, see after the initialization, so P1 still has the first name John, but P2 has the first name Johnny and last name Doe. Okay, so let's check the result on the screen. Okay, so here and a new object has been created with the name Johnny. The two things to remember here is, firstly, with a with keyword, it creates a new object and initializes the values. Okay, and secondly, with a with keyword, you can change immutable properties. Okay, one other thing you could do if you wanted to change the value of P1, even though it is immutable, you could reassign P1 again. Okay, and here after that change, you will see that the value of P1 has changed. Okay, so that's a small hack, not hack, but you can explore this feature if you want to change your code type declared in the standard property syntax. Okay, so let's check P1. So the value have changed, Johnny, and last name remained the same. Okay, so that was another point about the equality check. We already covered the with expression, and now we're going to check about inheritance. Okay, so for inheritance, well, we create another record type called student. Okay, it has the same properties like first name and last name, and an additional grade. Okay, and it inherits from the person record type. Okay, okay, so for inheritance, it is important to know that the first set of properties must match the base record type, otherwise the compiler will indicate an error. Okay, so object reference is required, okay, for non-static field. So very important that our first properties matches the base type. Okay, now I can create a person record instance. Okay, I can create a student instance, okay, with first name, last name, and the grade for the person, first name and last name. Okay, but I also create a person instance and assign an instance of the student record to it. Okay, and now when we use the equality operator, to check the student record and the person record, since both of them have the same first name, last name, and grade, even though the record types are different, they are equal. Okay. Just to confirm. Okay, so after this statement, let's see. Okay, so true is displayed. Okay, since the base type of student is person. Okay, so that's it, guys, for the C# record types. Well, for the C# record types, the key points to remember is that records created with a standard property syntax or immutable, so the properties internally or init-only setters. Okay, and records can't inherit from a class and vice versa. These a class cannot inherit from a record. Okay, so value equality checks if a record is of the same type and the internal property and field values match. And we have a built-in support for display, where the record type name is displayed, followed by properties name. Okay, within braces. Okay, so if you like my video, guys, please like and subscribe to my channel. Thank you. Bye bye.